To the best of our knowledge, Earth is the only known planet with life. This is quite surprising, given that we have discovered thousands of planets since the discovery of the first exoplanet in the mid-1990s. Since then, we've discovered a variety of techniques for finding planets orbiting stars other than our Sun, the most notable of which being planetary transits and Doppler shifts, commonly known as radial velocity measurements. Recently, the technology to directly photograph the planet was developed. However, these photos are still very low quality and do not reveal much information about the planets. A planet must be within a star's habitable zone in order to possibly contain life. A habitable zone is a region of a star's orbit where liquid water may exist on its surface. NASA's Kepler mission has discovered several possibly habitable planets, including Kepler 22b. In contrast, it has discovered a large number of planets with extremely harsh conditions. So in today's video, we'll look at some of the most bizarre exoplanets ever identified by scientists. A recent study claims that scientists have clearly detected an invisible extraterrestrial planet for the first time by observing how its gravity influences the orbit of a neighboring world. Both alien planets, known as Kepler 19b and Kepler 19c, were discovered by NASA's Kepler Space Telescope. Kepler discovered 19b as it passed in front of its host star, or transited it. After noticing that 19b's transits arrived a bit later or earlier than expected, researchers deduced the existence of 19c. The gravity of 19c pulls on 19b, causing its orbit to change. According to the researchers, the discovery of Kepler 19c is the first time this method, known as transit timing variation, or TTV, has robustly detected an exoplanet. However, it is unlikely to be the last. My expectation is that this method will be applied dozens of times, if not more, for other candidates in the Kepler mission, said research main author Sarah Ballard of the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts. In March 2009, the Kepler spacecraft was launched. It typically searches for extraterrestrial worlds by detecting telltale dips in a star's brightness caused by a planet crossing the star's face from the telescope's perspective, obscuring some of its light. Kepler has had a tremendous amount of success with this so-called transit method, detecting 1,235 potential alien planets in its first 4 months of operation. That's how it discovered Kepler 19b, a planet 650 light-years away in the constellation Lyra. According to the researchers, Kepler 19b has a diameter around 2.2 times that of Earth and orbits its parent star 8.4 million miles, 13.5 million kilometers away. The planet's surface temperature is most likely approximately 900 degrees Fahrenheit, 482 degrees Celsius. Kepler 19b passes through its host star every 9 days and 7 hours. But as Ballard and her colleagues discovered, that number is not constant. Transits can occur up to 5 minutes early or late. That variation indicated that another planet was tugging on 19b, speeding it up and slowing it down. In our own solar system, scientists used similar approaches to predict the existence of the planet Neptune. Astronomers found Uranus did not orbit the Sun exactly as expected and hypothesized that it was being pulled by an unknown planet. This prediction was confirmed in 1846 when telescopes confirmed Neptune. At the time, researchers know very little about Kepler 19c. It takes the alien world 160 days or fewer to orbit its host star, and the mass of 19c might range from a few times that of Earth to 6 times that of Jupiter, according to researchers. However, 19c should become more visible in the near future. It's a mystery world, but of course we don't expect it to remain a mystery, said research co-author David Charbonneau, also of the Harvard-Smithsonian Center for Astrophysics. Kepler and large ground-based telescopes should help us figure out its true identity soon enough. We witness advanced alien civilizations all the time in today's movies. The existence of other sentient species on a distant planet in a distant galaxy is not as far-fetched as it once appeared. Granted, we have a long way to go before we can casually visit any of our galactic neighbours, but the mere possibility of life existing on a planet other than ours is entirely within the scientific scope of our time. That is why we are looking. We're searching the skies using several detecting systems, and for the most part, what we're looking for are exoplanets. Exoplanets, specifically Earth-like planets orbiting Sun-like stars, represent the most likely setting in which life will develop independently of our planet based on our current understanding of life in the cosmos. So far, a few thousand exoplanets have been detected, although many have yet to be confirmed, using a variety of detection methods, some more prevalent than others. The majority of exoplanets are currently discovered using radial velocity and planetary transits, but other methods include gravitational microlensing, which uses the magnification of light due to gravity as a planetary litmus test, and pulsar timing, which detects changes in neutron star pulsar orbits caused by orbiting planets. While all detection methods are useful, some, such as transits, are more reliable, easier, and beneficial in terms of the information we can obtain. Far away in the constellation Cygnus, 3,849 light-years to be precise, lies a subdwarf B star known as Kepler 70. It is a significantly smaller star than the Sun, having a radius of 0.203 solar radii, or about 1/5 the size of the Sun. It is also far less massive, weighing only 0.496 solar masses. The luminosity, on the other hand, is 18.9 times larger than that of the Sun. Kepler 70 is a very old star that has gone through the whole main sequence and red giant stages of its life. According to estimates, Kepler 70 left the red giant stage 18.4 million years ago. Since then, the center of the star has been fusing helium. When the supply is deleted, the star will die by condensing into a white dwarf. When a planet's orbit coincides with the same orbital plane visible from Earth, the planet will cross in front of or transit the star once every orbital period. As a result, the visible brightness of the star decreases in relation to the size of both the star and the planet. In contrast to previous planetary detection methods, the transit method can determine the radius of a transiting planet. An extrasolar planet requires 3 or 4 transits to be formed. The transit method is used by NASA's Kepler spacecraft to detect new planets surrounding stars, including 2 discovered by Stéphane Charpenais around Kepler 70. Kepler 70b, the innermost planet, has one of the most severe conditions ever discovered on a planet, although some of its traits are remarkably comparable to Earth. It has a density of 5,500 kilograms meters cubed, which is quite close to Earth's density of 5,515 kilograms meters cubed. However, it only accounts for 44% of the Earth's mass. Despite some parallels, the atmosphere on Kepler 70b is simply too harsh for life as we know it to survive. The main and significant challenges to life on Kepler 70b are its lack of an atmosphere, proximity to its host star, severe temperatures, and the fact that it was recently within its host star. Kepler 70b is no longer a planet in the traditional sense. Rather, it is all that remains of a gas giant that originated with the original star system. Kepler 70b was most likely a hot Jupiter millions of years ago, a Jovian-sized planet that orbits extremely close to its host star. In the case of Kepler 70b, the planet orbits the star at a distance of only 0.006 AU. Mercury orbits the Sun 65 times further away than Earth. This is far inside the inner boundary for the habitable zone of Kepler 70. Both conservative and optimistic measurement, which range from 4.13 to 6.08 AU and 1.95 to 7.39 AU respectively. Around 18.4 million years ago, Kepler 70 grew to become a red giant as it aged. Because of its close proximity to the host star, 70b was literally swallowed in the expanding star's atmosphere, destroying its atmosphere. Planets in this environment are normally dissolved by the tremendous temperature and pressure. However, some Jovian-sized planets are large enough to support life. The planet's iron core is all that remains as the star departs its red giant stage and begins to shrink. The temperatures of such an object are, of course, incredibly high. With a surface equilibrium temperature of 7,288 Kelvin, Kepler 70b is now the planet that holds the record for being the hottest planet ever discovered. Is life possible on this planet? In its current condition, life as we know it cannot survive on Kepler 70b. It circles Kepler 70, which is far inside both the cautious and optimistic habitable zones, and is approximately 65 times closer to its Sun than Mercury is to ours. This not only leads in surface temperatures that are higher than any temperature on Earth where life exists, but it also results in a complete lack of water in any form on the planet. Planets without surface water may contain significant levels of water vapor in their atmospheres where conditions allow it, but Kepler 70b has no atmosphere to hold water vapor. Without an atmosphere, there is no potential energy source from which organic compounds may derive energy. The planet's solid iron composition provides more evidence against life on Kepler 70b. In fact, the surface is quite likely entirely molten, making life impossible. It's possibly that life existed on it in the past. Scientists believe that microbial life may exist on Jovian planets such as Kepler 70b. This life would have to exist at incredibly high altitudes in the atmosphere in order to be at habitable pressures and temperatures, as well as be near the water vapor that exists there. It would have to be buoyant enough to stay at that elevation in order to do so. Even so, any life on the planet would have been destroyed when Kepler 70 burst into a red giant. The expanding star entirely destroyed the atmosphere and temperatures quickly increased. The Kepler 70's eventual engulfment of the planet would have been the final nail in the coffin. Any organic substances would not be able to thrive within a star. Even after Kepler 70b departed the star, it has only been 18.4 million years, which is far too short for any life to form on the planet, even if the conditions were ideal. Furthermore, Kepler 70b is orbiting a star at the end of its life. In cosmic terms, this star will soon become a white dwarf, commencing its latter stages of existence. Observations of planets orbiting comparable-sized stars, particularly those this close, suggest that the planets become tidally locked far sooner than life would arise on the planet. This is true even for planets in the habitable zone, let alone planets as close to the star as 0.006 AU. It will be impossible for life to evolve once the planet becomes tidally locked. Let's hear what you have to say about these exoplanets in the comments section.